You can see a balloon that is tied with a string. The gas filled in the balloon is helium, all right? And you know the density of helium is always less than the density of air. And what is the reason? Because helium is a lighter gas than the air. We know that in air, oxygen and nitrogen makes the major part of air, and both are heavier gases. So O2 and N2 are both heavy gases. So because this balloon is inside the fluid, inside the air, that's why the air will also exert force on the balloon that we can call buoyancy. The upthrust force, the force that is exerted by the air upward. I will show you in the free body diagram as well. As you see, it is tied with the string, so there is a stretchness in the string, due to which the force should be downward, the force of tension. Since the helium has its own weight, that's why there must be the another force that should be the weight of the gas in the balloon. Anyways, so before cutting the string, this balloon is in equilibrium. Why? Because as I told you that there must be the buoyancy, the upthrust force exerted by the one fluid on the other. All right, so this is the buoyancy, that is rho gv. So density of the liquid, and I mean the density of the fluid, that is of course air, so rho a. Whereas the other force is the weight of the gas inside. All right, so the weight of the Fg, let's say. And the third force that is exerted downward is the force of tension, because this balloon is tight. Overall, before cutting the string, these three forces are balancing each other, making this object in equilibrium. All right, so Newton's first law is applied right now because there is a no acceleration. What will happen after the question is that what is the initial acceleration by the balloon as you cut the string? So when you will cut the string, we can imagine that the force of tension will now not in this picture. Now there will be a resultant force. So after cutting the string, now once again let's draw the free body diagram. So I'm going to draw the same length of the vector, that is the buoyancy upthrust force applied by which fluid? The fluid in which we have placed the balloon. That's the density of air times g times volume, the volume of the balloon. All right, so this is a collectively a force applied by air on the balloon. All right, now secondly, the weight of the balloon is a very small vector downward. Okay, now remember that we know that the weight is always mg. So the mass of helium, all right, okay, so we will write mass of helium, Heg. So you know very well that the density is always equals to mass over volume. So the mass of helium must be equals to the density of helium, which is less than the density of air. All right, making the weight less in magnitude. All right, so together these two forces are making the balloon now unbalanced. So what is the resultant force? So resultant force must be the upward force minus the downward force, which I can write the density of helium GV is equals to F is equals to ma. So this m is the mass of helium, or the mass of balloon, which is in fact the mass of helium, all right, times acceleration. Okay, so we can take the GV factor out from this, so we get rho a minus rho he is equals to the mass of helium is equals to the density of helium times volume, all right, is multiplied by a. So finally we have calculated the initial acceleration, which will in fact decrease. All right, so that is g, and we may cancel this v on the both sides, so that's why the a is the only possible answer.